Hey everybody, I'm going to make a tutorial on how to determine the density of the original culture, or the original culture density, by serial dilution methods. Okay, so I'm going to utilize the example that's in the slides for the lab, right? So I've kind of replicated that picture here on the whiteboard, okay, where we've set up a serial dilution. We've got a culture, right, our original sample that is has a lot of bacterial cells in it, and we want to determine what the density or the concentration of those bacteria are in CFUs per mil. So CFUs per mil is the concentration that we're looking for in this original culture. So we do a serial dilution, 4 different tubes, where we transfer 1 mil from the original culture into tube number 1, which contains 99 mils of diluent, right? So this could just be water, for example, sterile water. Then we mix and we transfer another 1 mil to this tube that also contains 99 mils. Another mil into tube number 3. This time this tube contains 9 mils, and then finally 1 mil into tube number 4 that also contains 9 mils. So the final volume in tube number 1 after we do the transfer is going to be 1 plus 99 is 100 mils. This is going to be 100 mils. This tube's going to have 10 mils, and this tube's going to have 10 mils. Okay, so we need to know what the important numbers are: the amount that's transferred, the volume transferred, and the total volume after transfer in each tube. So we need to determine what the dilution factor is for each step. So what's the dilution factor from the original culture tube to tube number 1? So that would be 1 step, so a single dilution factor. Okay, so we determine dilution factor by volume transferred over total volume. So the volume transferred is 1 mil, the total volume is 100 mils. So that's a 1 to 100 dilution, or the same thing as 10 to the minus 2. Okay, so an easy way to remember this is if it's got 2 zeros in the bottom, then that's minus 2. If it had 3 zeros on the bottom, so it were 1 to 1,000 dilution, it would be 10 to the minus 3. Okay, so now what is the dilution factor from this tube to this tube? Well, it's still 1, and then the final volume is 100. Again, the dilution factor is the volume transferred, 1 mil, divided by the total volume, which 1 plus 99 equals 100. So that's another 10 to the minus 2 dilution. Now we go 1 mil transferred, and then the final volume is 10 mils, so 1 to 10. So that's a 10 to the minus 1 dilution. Remember, that's just getting from here, from this tube to this tube. And then from this tube to this tube, it's also 1 to 10. So that's also 10 to the minus 1. So these are the singles, the dilutions with each step. From this tube to this tube is 10 to the minus 2. From this tube to this tube is 10 to the minus 2. From this tube to this tube is 10 to the minus 1. And then from tube 3 to tube 4 is 10 to the minus 1. What we need is the total dilution factor at each step. Well, step 1, the total dilution factor is equivalent to the single dilution factor. It's just 10 to the minus 2. Okay? But the total dilution factor for here to here to here, you add the exponents of the single dilution factors. Okay? So this one's 10 to the minus 2, but here it would be 10 to the minus 2. So what you're actually doing is multiplying the dilution factors. So 10 to the minus 2, that's from here, times this one, another 10 to the minus 2. And when you multiply them, that ends up being like you've added the exponents. So minus 2 plus minus 2 is 10 to the minus 4. Okay? And then what's the single dilution factor here? Well, you multiply the steps, 10 to the minus, the dilution factors at each step. 10 to the minus 2 times 10 to the minus 2 times 10 to the minus 1. That's minus 2 plus minus 2 plus minus 1 is 10 to the minus 5. And then this last one here, okay, or what I could have done there is just said, okay, this one's 10 to the minus 2, this one's 10 to the minus 4. We've added another dilution, which is 10 to the minus 1, so minus 4 plus minus 1 is minus 5. Well, minus 5 plus minus 1 here is 10 to the minus 6. Okay, so now we know our dilution factors at each step, and more importantly, we know our total dilution factors in each tube. So what this means is the dilution factor in tube number 1, the total dilution factor is 10 to the minus 2. The total dilution factor in tube number 2 is 10 to the minus 4. The total dilution factor in 10 to the minus 3, in tube number 3 is 10 to the minus 5. And the total dilution factor in tube number 4 is 10 to the minus 6. Okay? Now we need to determine, well, let's say if we plate a particular volume from each tube. So from tube number 1, we're going to plate 0.1 mils and then incubate it and count the colonies. Well, after we plate 0.1 mils and we incubate the plate, it's too many colonies to count, right? If it's more than 300, you can just say too many to count, or sometimes you might see TN for too numerous to count. Means the same thing, too many, okay? In tube number 2, we plate 1 mil and get 756 colonies, or 756 CFUs. Remember, these are in CFUs, colony forming units. 756 falls outside of our magic number range, which is between 30 and 300. So this number right here is not a good number to use to determine our original culture density. And this tube number 4, we plated 1 mil. I didn't write it here. I have to work around this picture because this is a picture that my daughter drew a couple weeks ago, and it says, do not erase. So we've got 1 mil from tube number 4, but we only have 12 colonies, or 12 CFUs. Okay? Too few, right? Less than 30. But I skipped tube number 3. Tube number 3, we plated 1 mil. After incubation, we count 132 colonies, or 132 CFUs. That is perfect because it's between 30 and 300. And so now we have everything that we need. We have 132 CFUs. And in that tube, in the tube where this sample came from, we need to know what the total dilution factor is in that tube. Now that we've determined which tube we're going to use because of the colony count, we can ignore the other tubes, and we don't need the total dilution factors in these other tubes. So the total dilution factor in tube number 3, because we got 132 colonies after we plated 1 mil, the total dilution factor is 10 to the minus 5th. Well, so you need to know this formula. The original culture density, OCD, is CFU, so the colony forming units, over VP, volume plated, times the reciprocal of the total dilution factor. Okay? So now, as long as you know that formula, all we have to do now is plug in the numbers. So CFUs, 132. Volume plated, 1 mil. And the reciprocal of the total dilution factor for that tube, 1 over 10 to the negative 5th is just 10 to the 5th. Okay? So now this is basically 132. I'm going to write it sideways here because I'm running out of room. This is mini-me, by the way, in case you were wondering. 132 times 10 to the 5th CFUs per mil. But that's not quite proper scientific notation. So we've got to carry this decimal, we've got to move it back so that it equals, so it's 1.32 times 10 to the 7th CFUs per mil. Okay, so this is our answer right here. Excuse me, mini-me. This is our answer. Okay, 1.32 times 10 to the 7th CFUs per mil. What does this number represent? This is the density of the cells in this original culture right here. So the original culture density, this is the original culture, okay, is 1.32 times 10 to the 7th CFUs per mil. I guarantee you that there will probably be a quiz question, or at the very least there will be questions on one if not both of the lab practicals relating to what I just did here. So practice, practice, practice. I hope that was helpful. I'll see you in lab.